All right, everybody. Thank you very much for coming to this Arduino workshop hosted by Andrew. I am Kyle Damerel. I'm the technology director at UTDL. Here at UTDL, we host a number of workshops from CAD and SolidWorks and Fusion 360, ANSYS simulation, 3D printing, AutoCAD, and today our Arduino workshop. We're all about going from the digital to the physical workspaces, bringing that virtual prototype to life, and bringing a creation throughout. Our workshops are guided to help everybody in the real world, going through school projects, and to ideally help you at our design-a-thon, which we'll be hosting around the beginning of February. More information on that can be found on our website. This workshop will be recorded and posted on our YouTube channel at utdl.tech if you search in the YouTube search bar, and will also be made available on our website. For more information, there'll be an email link at the end of this presentation, and you can always find more on our website. Thank you, and now to Andrew.
Thank you, Kyle, for the introduction. Hello, everyone. I hope you're doing well. So today we'll be doing our Arduino workshop. Let's get started. I'm very excited. So before I do that, can you guys hear me all right?
Yes, we can hear
Feel
you.
free on my side.
Okay, perfect. Awesome. So let's go over the agenda. So today I want to talk about the Arduino itself. Just give you a brief introduction of what it is all about. It's, you hear it around a lot. It's really popular. I want to let you know what it is. Then we want to talk about the hardware components available to us today, the electronic components, the IDE that we use for programming, how do we do programming, like the syntax and the different logic statements, Boolean algebra, things like that. And then I'll go over a brief virtual simulation online for an Arduino servo motor control, as well as a few examples of the actual programming itself, so that you can do that yourself after the session as well. Perfect. So the name Arduino is thrown around quite a bit in design competitions, engineering prototyping, DIY projects, things like that. But what is it? So Arduino is a open source set of hardware and software components that individuals of all backgrounds really can utilize. So a lot of times today it's used for engineering prototyping for smaller electronic projects, and it's used in that aspect because of its very low cost, right? Because it's open source, there's a lot of different components you can use with Arduino outside of Arduino Kit that you can outsource, right? And there are a variety of different hardware components and electronic components within the Arduino family itself that you can use as well. So Arduino has a family of different boards. Today we'll be mainly focusing on the Arduino Uno, but keep in mind there's also other open source boards such as Arduino Nano, the Mini, and the Mega, right? So there's also a variety of different peripheral electronics components, such as the expansion board or the breadboard, which we will get to later, different um, resistors, transistors, capacitors. We'll also get to sensors, motors, LED emitting diodes as well. Okay, so here's just a few example projects to get you started with, get you excited about this whole Arduino thing. And what can you really make with Arduinos? So on the left, you see a electric car with a DC motor attached to the front. So what that car does is you can drive it around based on just controlling the DC motors. You can drive it around using some of these sensors you see attached at the very beginning. You can control some of the lights that are currently soldered in the very front of the car. The second example is a robotic arm. So here you can see our DC servo motors at the very end of the um, machine is actually sourced from Arduino, right? It's a third-party servo motor actuator that we're using to control the arm. This is an example of how you can outsource different components. The same thing applies to the servo motors at the very front, the one that controls the claw and the one that controls the main motion of the arm. These are not Arduino servo motors. These are just a third-party servo motor that you can control. A three-pin servo motor you can connect to the Arduino board itself so that you can control them. And then the third image on the right shows Arduino connected to a large breadboard to Lego components, right? So um, these motors are from Lego. If you recognize them, um, they can be used with Lego components, or you can assemble these components with open source parts. You can 3D print parts modified to fit the pins of the Lego motors. And this is an example of a cross-platform collaboration between Arduino and Lego, where both are compatible with each other. So essentially, in this case, you'd program using the Arduino, and all the physical tasks will be carried out using Lego motors and sensors. Right. And you might be wondering, holy crap, there's a lot of stuff on this very small Arduino board, right? It's the Arduino board is half the size of your phone. The Arduino Uno is very small, it's very compact, but it has a lot of functions. So next I want to do a schematics overview for the Arduino Uno. And here is a very general overview. You don't have to write this down because we're putting this image on the screen for you as we go through each and every pin. And let's start with power, right? So there's two ways you can power this board. You can power this using a USB plug. This is the first way. You can tether this to your computer, or you can use the external power supply. So this is something that you would have to plug into external battery or to a wall. Right. Here's a reset pin. It's basically a duplicate for the reset button. You would connect this to um, yeah, so the reset button is over here. It's not highlighted. The reset button essentially turns the board on and off, and the reset pin would do the same. So if you connect the reset pin and a ground pin to a button, right? So here's a reset pin. Here are two of the ground pins, and you connect a button over here. It would essentially duplicate the function of the reset button. Next, I want to talk about the 3.3 volt power pin. So this is the second pin to the left on the bottom. Right? It's all labeled on the board. So if you have difficulty um, remembering, right, just know that the 3.3 volt is a power pin that you can use to power, for instance, a 3.3 volt DC motor. Right? DC motor is usually 5 volt, but if you want to do 3.3, that's okay too. Right? The same thing applies to the 5 volt power pin. Right? If you want to connect a 5 volt DC motor to the 5 volt power pin and the ground pins, you can do so using these two pins. And next is voltage in. So this is where you can connect a 9 volt power supply to the DC voltage in, and that will simulate a 9 volt power supply through the external power supply port. Right? So the first way you can power this board is USB plug. That's usually 5 volts. Right? And the external power supply is usually 9 volts when you connect to a battery or when you connect it to a wall plug. And then if you want to use the voltage in instead of the external power supply, it's essentially a identical replacement for what you use to replace this barrel plug, right? Yeah, so next we have the ground pins. So nothing really special about them. They're just regular ground pins. But something that we should keep in mind is establishing common ground when you plug in a circuit. So you want to make sure that the ground pin on the Arduino, as well as the ground pin of any of the electronic components you're using, such as an LED diode, as well as the ground pin of the power source, is all connected. Next, let's go over the analog pins. So these are the analog pins A0 to A5 on the right bottom corner of the board. So the analog pins can be declared, right? They can be converted from analog to digital. I would call that analog digital conversion. So it could be used as either analog pins or digital pins. And in digital, you have digital input or digital output, right? And then here's a programming syntax that I'll get to later. You can use an dot analog read to read the analog input. So next, I want to talk about the in-circuit serial programmer. The ICSP is usually used for burning a bootloader to the chip that we have. Right? This is the 80 mega chip that controls the Arduino Uno board, and the ICSP is used, for instance, when the part of the hardware is damaged or when you need to modify the firmware on the Arduino board without making hardware modifications. We really don't do this. It's only when you're in intense developer mode that you need to change the firmware of the Arduino Uno. And next we have the serial out and serial in pins, or the TX and RX pins. And these, just like how the external power supply can be replaced by the voltage in, the USB plug that is tethered to your computer can be replaced by the TX and RX pins to simulate some sort of a communication structure with your laptop or computer, or other devices. And then lastly, we have the digital input and output pins. So these digital IO pins can be declared to act as either input or output in the Arduino IDE programming interface. Right, so you can use these to read from sensors, or you can use these to control devices like servo motors. And then lastly, there's the analog reference pin, or the AREF. So the AREF by default, right, is a 5-volt reference, which is the same as the operating voltage on the board. This can be declared externally from 0 to 5 volts. So for instance, if you want to measure a voltage between 0 to 2 volts, you can connect a regulated 2-volt supply to the AREF and use it in conjunction with one of the ground pins, so that whatever you measure, right, from the analog read function that we talked about before, is measured more accurately from 0 to 2 volts instead of 0 to 5. Next, I want to talk about the expansion board or the breadboard. The extension board comes with a variety of sizes, right? But here's what you need to know. The diagram shows different lines. There's black lines, red lines, and blue lines. And all these lines are connected, right? So you see the pins 1 to 30 on the top and the very bottom connected, and the pins A to E and F to J vertically in the middle are connected. And if you connect these two rows with a jumper cable, the entire row is connected. Right, so there's a lot of things you can do with this expansion board. For instance, you can connect it to electronic components. And next, so let's talk about some of those. Here is an overview of the motors and actuators we can have. A DC motor usually runs on 5 volts, and the direction of the DC motor is controlled by polarity, and the speed is controlled by voltage, right? So let's say the maximum voltage for a particular DC motor is 5 volts. You can declare the actual voltage in the Arduino IDE from 0 to 5, and then it will spin at different speeds, and the power will be different. On the other hand, there's servo motors, which you may have seen this particular servo motor in the electronic arm that I showed you in the beginning as one of the example projects. This particular servo motor can rotate only 180 degrees. It can't keep going. You have to rotate backwards and then do it again. There's also stepper motors. It's controlled by stepper controllers that you need to wire externally to the board. Right. So this is like you need to have an extension board to be able to wire a stepper motor. The stepper motors are controlled by a very specific voltage input and pattern, and it can be preset as to 0.8 degrees. These stepper motors are also known to have much larger torque than some of the smaller servo motors or the DC motors. Right, next I want to talk about LED diodes. These you could have seen on the first example in the 3 project examples I showed you at the beginning. So these emit light when a current passes through a component, and the brightness can be controlled and adjusted based on the current. Right, so you can see here there is a long wire and a short wire coming out of the LED diode. And the long pin is for voltage in. And remember how we talked about common ground? You have to always have this ground connected to the ground of the board, Arduino Uno. So the short pin is the ground, and make sure you connect that. Whether directly, you can solder a wire into it, or you can put it in an X-bench board. And then there's single color LEDs. There's also RGB color LEDs where they can display a lot of colors, or you can use a combination of single color LEDs to generate the light spectrum. So next, I want to talk more about the sensors that we have. We have light sensors, ultrasonic sensors, touch sensors or buttons. There's sensors that are sound activated, gyroscopes, temperature sensors. There's a variety, right? So light sensors would be able to measure the brightness, for instance, in a room, or brightness reflected off a surface. And this is something that you can use digital read to determine. Ultrasonic sensors are able to measure distance. Touch sensors are able to measure touch. Sound activated sensors are detecting detecting sound and activated by sound. Gyroscopes can detect movement, especially in turning and rotation. And then temperature sensors are sensitive to heat. Now let's talk about more the electronic components. So here are a few images of resistors. They slow down the flow of electricity throughout the Arduino Uno and externally, and that will prevent excessive voltage from being applied to different electronic components. So to protect an LED diode, you really connect one of these to them so that the power, the voltage from the board doesn't actually fry the LED itself. So the resistance is measured in ohms and is represented by these 4 or 5 color bands on the resistor. So here are some examples of if you need to calculate the resistance of a resistor. Now there's a table for it. It's really easy, and I'll just give you a few examples here. Right. So the resistors can have up to 6 bands. Usually the first 4 or first 3 will determine how many ohms of resistance or kilo ohms of resistance the resistor will have. So then, for example, you see the first band is orange, right? And when you see that, you will go onto the chart and you find orange, and you will go to the first one, right? And it's a 3, and you write down 3 here. Right, second one is red, you do the same thing, but it's for the second digit, and that's a 2, you write down 2 here. And the third one is brown, go to brown, it's a 1, you write down 1 here. And the fourth one is brown as well. And so the fourth one will be what you multiply the value you just got by, and you have 10, right? So that multiplied together, right? The 3, 2, and 1 wouldn't be multiplied. It would just be the 3 digits of your resistance. And then you multiply it by the factor in the 4th digit, and you get the resistance in ohms. So 321 times 10 is 3.21 kilo ohms. And the same thing would apply to the 5-band resistor as well. So the first 3 digits are, again, the 3 digits of the resistance, and the fourth one will be the factor that you multiply by. The fourth, the 4-band resistor and 3-band resistor essentially works the same, except it has one less significant digit. And don't worry too much about the other stuff: tolerance, temperature coefficient, or fail rate. And then next, let's go over the transistors and diodes that are available. So a transistor switches on and off an electrical power source. So in Arduino, it can output the value between 0 and 255, with 0 being no power being delivered and 255 being the maximum power delivered to another electronic device. On the other hand, a diode allows the current to flow only in one direction. And that is another agency which protects the Arduino Uno board. So for instance, when a DC motor is turned off, it keeps when the power supply of a DC motor is turned off, right? The DC motor may still keep going. Right? There's no braking system for the DC motor, which means that a negative current can be generated to flow from the motor back to the source. Right? It's like when you spin a turbine, you can generate electricity. But in this case, it's actually damaging to the Arduino board. So the diode would essentially block that negative current from entering the board and damaging any of the components or impeding the performance of the board itself in other functions. So next, let's do a quick overview for the Arduino IDE programming software. It is open source and it can be downloaded for free on arduino.cc. And here's a general overview for what programming looks like. It's very similar to C++. So you have your general operators, the assignment operator. So you can say x, which is a variable, is equal to, you use this assignment operator, and you can declare a specific value. So you can see that in pin declarations later. If you want to do general math, you use addition, subtraction, multiplication, division, modulo, and these will be just very general algebraic operators that you have. You can also use equal to. So for comparisons, if the value of x is equal to such and such, then you're not really assigning a value for x. You'll be using the equal to operator. And same thing with not equal to. If you're trying to figure out if something is not equal to something, you want to see if that's true or false, then you can use that function. And same thing applies to less than, greater than, less than or equal to, as well as greater than equal to. There's also Boolean operators, and or not, and those would be represented by the symbols above. Right, so exclamation mark for not, double bars for or, and double ends for and. Here are some compound operators. Right, so if you want to do an increment by 1, so for instance, if you want to say variable a equals to b plus plus, that would be that would make variable a equals to b plus 1. So same thing applies to b minus minus. So let's say we want to know the value of a, which is equal to b minus minus, and then we say b is equal to 10 at the very beginning of variable declarations. That will make a 9. Right? And then next you have the compound addition, subtraction, multiplication, and division. And those would be when you want to increment, decrement, or if you want to do multiplication or division by a specific number, right? So for instance, if I want to increase b by 2, then I can't really, I can use the increment function plus plus twice, right? But that wouldn't be very convenient. I can just declare here b plus equals 2, right? So that would set b, let's say at the beginning is 5, now to 7. The same thing applies to subtraction, multiplication, as well as divided. So here's a general overview of the programming structure, what that should look like in Arduino IDE. So at the very beginning, you should have void setup and void loop. So void setup is for you to declare any pins so that the Arduino IDE knows how you have set up the Arduino Uno board physically. And void loop is for the actual function that you have, the tasks that you want the Arduino to perform. You have the if-else loop. So it's essentially the same for an if statement. For instance, in Python, and the structure will go if, let's say, a variable is less than 5, perform a certain task, else perform another task. Next, I want to go over the switch function. So a switch allows you to identify a variety of cases or situations and then perform very specific tasks. A switch is essentially an if-else loop with ifs and many other else-ifs. So you can declare the different cases. You can start the switch. You can name the switch. You can declare case 1, something, and then perform a certain function, case 2, and then at the very end, you declare what is the default case. That is the one that the Arduino programming software would detect first when performing a task. You can do a variety of different loops, the for loop, the while loop, and the do while loop. So for the for loop, for instance, you can define for the integer of I, a value between 0 and 255. And each time I is incremented by 1. That is one way you can set up the loop. And for that value of I, do a certain task. Right? And same thing for the while loop. You can say for while int I equals to a certain value, and then I minus minus, which each time it loops through decreases the value of I by 1, perform a certain task. And the do while loop is essentially the same, but you declare the function before the actual loop structure itself. If you want the code to continue, for instance, if you want to break out of the loop early, you can just put continue. If you want the code to stop running, or if you want to delay a certain function from continuing for a number of milliseconds, you can use the delay function. So 1000 here in parentheses will be 1 second. And if you want to return the value of a function, right, for instance, if you're measuring a certain diode or the intensity of light from a light sensor, then you can say return then the variable, the value of the variable, and then that will be returned to the Arduino IDE. All right, here's a bit more intensive coding. So these would be what actually operates the Arduino board itself in terms of being able to monitor the values of pins, assign different values to the pins. So digital write and digital read, what you would use that to define the output or read the input of a digital pin. So for digital write, you have to declare the value of the pin, so which one is it connected to, as well as what value you want to assign that pin. Right, so the pin number and the value assigned has to be declared. For digital read, it would read the input from a declared digital pin, and what it would return is high or low. Right, so we'll talk about the difference between digital and analog later. Do I see something here? No, okay, great. So for analog write, you can define output as a specific analog pin, and analog read, you can read the input of a specific analog pin between 0 and 10, 23, so 1023. And so the difference between digital and analog is that digital only reads high or low, and analog is able to read a very specific value from 0 to 1000. So I mentioned before that the analog pins can be converted to digital pins when you define. The same thing applies to the digital pins that we have, and you can define a digital pin as either a digital or an analog, and use that. You can do that through pin mode, right? You define the pin, and then you define the input and output for that pin. Next, if you want to tether your Arduino Uno to your computer, you can use the serial configuration functions. So serial.begin is used to set the baud rate for a data transmission, right? And that by default is 9600 for the Arduino Uno. And use serial.end to terminate the connection with the computer. You can also use serial.print to print data to the serial port. So that would essentially transfer a line of input from your Arduino Uno to your computer. Right, so before I do some examples of what programming would look like on the Arduino IDE, I want to go over how we can virtually simulate the Arduino interface online. So Tinkercad has a very convenient hardware simulation function, which I'll show you in a second. Here, hold on. Let me just close these real quick. Right, so if you go to Tinkercad, tinkercad.com, on the left you can see you can do 3D design, circuits, code blocks. Just click circuits, you can start a new circuit, or you can just take a look at the example that I have. This is from another designer on Tinkercad that I have just adapted the project for. And what this interface does, right, is that it allows you to use a variety of hardware components. Right? You have the Arduino Uno, you have different DC motors, servo motors, RGB LED diodes, a variety of different things, resistors, touch sensors. And it allows you to virtually simulate an environment where you don't have to actually have the hardware components physically with you to be able to prototype something. So that's extremely convenient, right? And even better, it allows you to simulate the Arduino without actually having to use the Arduino IDE code, right? You can just drag and drop different blocks. So for instance, use a title block. It kind of describes what the program does. It doesn't really matter. You can also have different comments. It's essentially the same as if you wanted to comment in your code so that when you come back, you understand what this subprogram does. And then you have a variety of different input, output definitions, controls that you can utilize directly in the interface to program the board. Right, so here I have rotate servo pin 9 to 50 degrees. And so you can see here physically I have connected pin 9 of the digital pins to the servo motor. So the servo motor, as I mentioned before, is 3-pin. One of them connects to 5-volt, one of them connects ground, and the third one will connect to one of the digital pins to be controlled. The same thing applies to the servo here on the right, which is connected to pin number 10. And so what I have here is rotate servo number 9, 50 degrees, wait a second, rotate it again to 100, and then wait to 150, and then do exactly the same thing for servo connected to pin 10. And after you do that, you can just click the start simulation, and then it would essentially run exactly what you just had here. Right, so we're turning servo 9, now servo 10. And you can modify this to your liking. So if you want to do 180 here, and then 100 here. Or you can do that and you can start simulation. There you go. Yeah, so this is just a easy way to introduce you to being able to physically simulate the Arduino online without having the hardware and without having to program using the IDE. Perfect. And well, and next I want to go over some programming examples. So the first one I want to go over is a introductory example to Arduino IDE programming, as well as the hardware itself. Right, so let's see if we can control a simple LED diode using just the board and a resistor. And yes, we can. Let me just zoom in on the code right here. So as I mentioned before, to set up the general structure, you need to use void setup and void loop, right? So in void setup, you define the setup that you have for the Arduino, including all the pins, right? So for the digital pins, we can define them as either an input pin or an output pin using pin mode. So here I'm defining pin 13, which I'm connecting my the voltage input pin of the LED diode to, and I'll define that as output. Right, so I'm essentially outputting power from the Arduino Uno to the LED diode, and I'm connecting the resistor from ground to the ground pin of the LED diode. And then in the second section, I want to define what I want this LED diode system to do. So since I connected the LED diode to a digital pin, I'm going to have to use digital write function. And remember how digital write has only high or low, just like how digital read has only high or low readings. If I want to turn the LED on, I'll use digital write. I'll define the pin, so it's pin 13, and I'll define that as high. Right, so that will essentially turn on the LED. I'm gonna wait for 1 second, and then I want to turn off the LED and wait for another second. So low would actually turn it off. Right, a very elementary example, and should be easy to understand. Next, let's see if we can use a button to control the same LED diode that we had in the last example. So before we have void setup and void loop, you also have the opportunity to define constants, global variables, and local variables. And so constants, they don't change throughout, and they can be used here to set the pin numbers. So to declare a constant, you just type in const, and then you want to define an integer. So you say const int, the name of the constant you're going to define, and the value that's equal to using the assignment operator. Right, so here, this is the number for the push button pin, which is pin 2. And you can see here in the image, it's the green wire is connected to pin 2 of the Arduino digital pins. Right, the same thing applies to light pin. I want to use pin 13, the same as last time, for the LED. And then you can declare variables that will change throughout the program. As integer button state. So that reads whether or not if the button is pushed. You can set that to 0, you can set that to 1. Initially, it doesn't matter. because we're going to read from the actual state of the button later in the program. So again, I define the LED pin, which I have defined before as pin 13 as an output pin. So the power is being outputted from the board to the LED diode, and the button pin as an input pin because I want to read the state of the button itself. So after the setting up what the Arduino setup is like, we can do a void loop for, again, defining the code, the function that we want the Arduino to perform. So we want to say first, before we actually turn on or off the LED diode, we want to read whether or not if the button is pushed. Right. So that we use that by using the button state constant, or sorry, button state variable that we defined above here in the variable section. And we define that, and we assign a high or low reading from the digital read function for the button pin to the button state, right? So if it's high, then we are going to turn on the LED. And to do that, you can use an if function, right? So by saying if button state equals high, that means the button is pressed. Then we turn the LED digital write LED pin, which is pin 13, is defined as high. Otherwise, we want the LED to be off, right? So digital write LED pin low. Here is the third example. Let's see if we can use a potentiometer to control the LED diode. Right, so again, we have our constant definitions. So the pin of the sensor is connected to A0. A0 is right here, the yellow pin right here. So remember, A0 to A5 are the analog pins that we have on the board. Yeah, let me zoom in. The LED pin again is 13, and then the sensor value at the beginning is 0. In terms of the setup itself, we want to declare the LED pin as an output, and same thing as before. And then in terms of the function definition, we want to assign the sensor value, just like we used the in example 2, we assigned the state of the button by doing a digital read of the button pin. Right? We're doing an analog read of the sensor pin, so we get a very specific value from the reading itself. Right? And so what this function is trying to do is we're reading a specific value from 0 to 1023, 1023 from the potentiometer, and we're turning on the light on and off based on how much the potentiometer is adjusted to in real time. Right, so after you read the value from your potentiometer, we input that into, we turn the LED on, and we input that value into how long it's delayed for. Right, so let's say I read 500 from the potentiometer, that would be 500 milliseconds or half a second. So I would essentially be turning the light on and off for half a second each. And I can adjust the potentiometer every single time, and then it will read a different value and turn the light on and off. And the frequency will be changed based on the value reading from the potentiometer. Right, so that's the difference between using digital read or analog read. Right? Digital read will only give you a value from high to low, but analog read will give you a very specific value from 0 to 1023. And that can be used to make more minor adjustments to, for instance, how long an LED sensor is turned on for. In the second to last example, I want to do a servo motor. right? So as we mentioned before, a servo motor is controlled by 3 pins. The first one is the 5-volt input. The second one is the ground. Again, we're establishing common ground by connecting the ground pin of the servo motor to the ground pin of the Arduino Uno. And then the third one is controlled by a digital I/O pin, right? And we would define that as an output. Right, so to use a servo, because servos are not usually made by Arduino, you have to include a library that people have developed for using servos and controlling servos. You can name your servo to be servo1. And then later you'll see, we use servo1 dot attach to connect to be able to connect it to a specific pin to be defined here, as well as the degree of rotation, right? So this is not extremely important. One thing you know is if you connect it to pin 9, define pin 9, the manufacturer will usually give you data on what's the max and min for how much you can turn the servo for. And after the setup declaration, here's a function declaration. You want to establish an integer called positions. So generally speaking, to control a servo motor, you have to provide it with the angle that you wanted to turn to, right? So these servos cannot turn a full 360 degrees, but you can turn it anywhere from 0 to 180 after it's reset. Right, so this function right here in the example, we're trying to change the position of the servo motor at full speed. So using servo1.write, we would essentially be doing a power output to the servo, saying, okay, let's turn on the yellow pin right here until the servo turns 90 degrees. Right? We want to wait 1 second. We want to turn it to the full 180. We want to wait 1 second. And then we want to wait, turn it to 0. So we reset it to 0. And then want to wait for 1 second. Right, and if you wanted to simulate that on the Tinkercad, you can do that as well. Right, this is essentially what we have, but we had 2 motors on the Tinkercad, and you can change 90 to 50, 150, and then 100 to simulate pretty much exactly what we had. Right. If you want to use 2 servos, you're going to say servo2. Right. You can copy and paste the same thing. And that's exactly what we have on the Tinkercad, right? You're turning 2 motors, 2 servo motors, controlling them to a specific degree. You're waiting 1 second in between. And you have to find the 2 servos above in the setup section. Right. So the second part would turn the servo incrementally, right? So we're turning servo 1 by here 2 degrees at a time for 20 milliseconds each step, right? So what happens here is we're using a for loop, and we're using a for loop for the servo position from 0 to less than 180, which is max, for an increment of 2 steps or 2 degrees at once, right? So we're using servo 1, so we're using servo1.write, and then we're using servo1.write, the output being the position, right? The position is going to change, so we're just using the position variable here. So that what that does essentially is the first time it turns, the position is 0 plus 2. So it will turn for 2 degrees, and the next time would be 4, all the way up until 180. Each time the Arduino Uno would wait 20 milliseconds. Right? And then next, we want to turn it from 180 to 0. But now each time for every 20 milliseconds, we want to turn the servo by 1 degree. So that would do the that would allow the servo motor to turn 180 times for 1 degree each until it's in the reset position again. And then you can use this module for, you know, I want to turn now from 0 to 100, but I want to turn 20 degrees at a time and wait 1 second in between. So that would turn the servo 5 times, right? For 20 degrees each until it becomes 100. And every time in between, I will wait 1 second for it. Pretty intuitive example for how you can control an actuated servo motor. Let's talk about DC motors. Example 5. Here we go. So right off the bat, you can see a transition here. We talked about how DC motors keep spinning and generate a negative current into the board and can damage some of the electronic components. So by using a transistor here, right? This transistor is connected to the ground pin. One of the pins is connected to ground pin there. The other is connected to the resistor, which is then connected to the control pin. And what that allows you to do is to actually just stop the negative current from entering the board and protect all the electronic components. So let me zoom in here. What we want to do here is, again, we're using a global constant to define the pin that the motor is connected to. Right. What you could do here, you don't have to declare this if you're, if you don't want to. You can just put 9 here, and you can define pin 9 as the output pin. But then later on, you wouldn't be able to use the variable motor pin. You would have to use 9 throughout. Right? But here it's really convenient because now it makes more sense when you read through the code. I'm declaring the pin that the motor is connected to as output, not just pin 9. And sometimes that's easier when you need to debug code that is very complex. Right? So here we define a constant for the motor pin as pin 9. We define the pin 9 on the Arduino Uno as an output pin, a power output. And in the function declaration, right, we declare 2 variables here at the beginning, on time and off time. This is going to be used later to turn on the motor and off the motor for 3 seconds each. So here's another example of how your variable declaration can be helpful in making the code more intuitive and easy to read, right? So instead of saying declare 3000 here in the delay section, if I need to use a 3000 value repeatedly throughout, right, I can just declare on time to be 3000 or any variable name for that matter. Right? And then I can use on time here. And the same thing applies to off time. And if I want to change all of the on time and off times, I only need to change it once here and once here. You have to go through the code and change all your 3000s to 1500, for instance. Right. So here we're turning the motor to full speed. 225 is the maximum power output for the DC motor, 5 volts. Right. So we're turning the motor to 255, which is 100% full speed. We're waiting 3000 milliseconds, which is 3 seconds. We're turning it off and then waiting the same. Just like how you can turn a servo motor incrementally, you can also change the speed of a DC motor to accelerate it or decelerate it incrementally as well, right? So there's not really a way to continuously do this, right? Unless you do some calculus and but you can also just decrease the speed one by one every time. Right? So what happens here is I'm defining a delay time of 20, just like how we have delay time of 20 here, right? But now I'm just using it as a variable. So for the speed of 0, which is stationary for the DC motor, to the full speed of the DC motor itself, I want to increment the speed one by one from 0 to 255 for 20 milliseconds each. Right? If I want to make it accelerate faster, I'm going to say 1 millisecond. So under 225 milliseconds, the DC motor will turn to full speed. I want to do it slower. In 255 seconds, the DC motor will now accelerate from 0 to full speed. And the same thing applies to decelerating the motor, but now I'm using the minus operator. Right, so this would turn the motor from full spinning speed to 0 incrementally. Right now, it would take around 1.5 seconds to perform the entire operation. Awesome. Now that we have gone through examples, you know how to control LED diode. You know how to read values from a sensor and then use that value as an output for another function. And you know how to control some of the physical components of the Arduino board. Here are some additional resources that can guide you through more complex performance and functions in the Arduino Uno. So as we mentioned before, Arduino is an open source project that people have developed for technology enthusiasts, engineering prototypers to use. And there's a variety of different guides. So the one I can direct you to is the one on the official Arduino website. So the Arduino guide offers a variety of resources for not only the hardware, but also the software and firmware as well for the Arduino Uno and a variety of other boards. Now there's a link to purchasing an Arduino kit. We can't really per se recommend specific kits. This is an example of how you can purchase a variety of different components at once. Oh, well, our servos is still going. Let's stop the simulation before they overheat. Therefore, it's a demonstration of how affordable these things are. For $40, you can buy a variety of different items. I see something in the chat. Thanks a lot. Okay, no worries. And if you guys have any questions, please feel free to contact us or ask now.
Awesome, Andrew. Thank you very much.